In the following video series, we will be examining the conic section of a parabola, looking at its definition, the different components of the parabola, and the characteristics of all the parts that we're going to be finding from a parabola. So let's move on to the definition first. When the distance from the focus of a parabola is the same as the distance of the directrix of the parabola, you have the conic section created. And what that's saying is if you go from the focus to a point on the parabola, we'll call this D1 for distance 1, and then you go from that same point to the directrix, we'll call that D2. For a parabola, those distances are equal to each other. It is the same distance. That is what defines a parabola. Now, what I want to look at when we are examining the parabola is look at the new points that we have not identified before. So when we've dealt with the parabola before, we've always looked at a vertex. That's not new. A new point that we're finding is our focus. So we're going to have to define how do we find the focus of a parabola, because it's part of the definition. The next new concept is this line, which we refer to as the directrix. Those are two new concepts we have not dealt with a parabola before. So we're going to have to examine these two components along with a different one. Let's move on and look at those components. First, for a vertical parabola. Now we have this nice little picture outline. I'm also going to write down some of the concepts for it. So right off the top, we see y equals a times the quantity x minus h squared plus k. This is our general form for a vertical parabola. We can see, just like before, when your leading coefficient is positive, it's opening up. When your leading coefficient is negative, less than 0, it's opening down. Now what we're going to look at is all the different properties, all the different components represented here. The vertex, just like before, is represented by the coordinate hk. So we can find our vertex. We were asked to do that same idea back in chapter 5. We also have our axis of symmetry. Now remember when we dealt with parabolas before, we said that for a vertical parabola, the axis of symmetry is x equals your h value of the vertex. So our vertex and axis of symmetry is not new. Those are the same that we've done before. The new concepts, the new components we're going to be finding are the focus and the directrix. So let's do the focus first. The focus right now we see is at this point on our picture. It is represented by the coordinate h, comma, k plus 1 over 4a. And I'm going to talk about that 1 over 4a soon because I want to look at the directrix next. Now the directrix you see is a dashed line on the graph and it's a horizontal line. So when you have a vertical parabola, the directrix is the opposite, it's horizontal. Now since it's a line, it's represented by an equation. And since it's horizontal, it's y equals, here it's your k value minus 1 over 4a. And so these two, if we were to take a look, they do look very similar. You have a k plus 1 over 4a and you have a k minus 1 over 4a. And if we take a look at this, the distance from the vertex to your focus, you're only going up, so it's only changing the k value, and you're changing the k value by adding 1 over 4a. So the distance from the vertex to the focus is 1 over 4a. The distance from the vertex to the directrix, here, you're taking your k value and you're subtracting 1 over 4a. So it's the same distance as 1 over 4a. I'd like to put a negative to show it's going the opposite direction for it. And so that is a property of the focus and the directrix, is that they are 1 over 4a units away from your vertex for it. And the last new component is what we have, the lattice rectum. We'll just call it the lattice. What the lattice does is it finds 2 points on the parabola, a point A and a point B. Now, the lattice, when we find it, we use the absolute value of 1 over our A, which we can get from our general form as our coefficient, and it's that many units long. And so what happens is the whole thing is that many units. So half of it occurs to the left of the focus, and the other half occurs to the right of the focus. So the key that you need to know here is when you find the lattice, you go half that distance to the left, and you go half that distance to the right to find 2 points on the parabola to graph. And so this is for a vertical parabola. Let's look at our horizontal. Now we're not going to spend as much time breaking everything down like before because the patterns are very similar to what we did with our vertical parabolas. Here, though, a horizontal parabola has the form x equals a times y minus k squared plus h. So the general form is a little different, but always know this. Your h is your horizontal and your k is your vertical. So k is always paired up with the y. So x equals a times y minus k squared plus h. That's our general form. And just like before, we have a vertex. The vertex is still represented by the coordinate hk. Now, a new concept for axis of symmetry is here the axis of symmetry represented by this green dashed line is horizontal. And since this axis of symmetry is horizontal, then that means it's y equals for the equation and your k value, because it cuts horizontally through the y value of the vertex. So for a horizontal, hk is still your vertex. The new concept is since your axis of symmetry is a horizontal line, you're going to use your y value of the vertex, y equals k. Let's go back to the next concept, our focus and our directrix, those two new components. When you're finding the focus, let's take in the definition we looked at before to understand this formula. We said the distance from the vertex to the focus is, based off of the vertical, we found 1 over 4a. So we're moving horizontally to the right from our vertex. So our h value will have 1 over 4a added to it. So the focus is represented by h, and since you're moving to the right to get to the focus from the vertex, it's h plus 1 over 4a. And since you're moving right, the vertical value does not change. The k does not change. If we go from our vertex to our directrix, we're going left 1 over 4a units. That's negative 1 over 4a. So you are moving left, so you subtract the 1 over 4a from our h. And since we're dealing with our h, that's our horizontal, and x represents our horizontal values, x equals our h minus 1 over 4a. So I know this is a very, very lengthy explanation of the components of the vertical parabola and of the horizontal parabola, but I'm trying to get you to see that if you know h, k, and a, you can find everything on the parabola based off of this understanding. And if you understand the focus, you should understand the directrix, because one's a plus and one's a minus, the same thing. 1 over 4a is the distance from the vertex to the focus, and the vertex to the directrix in the opposite direction, the negative. The lattice is still the same formula. The lattice is still found by taking the absolute value of 1 over a units. And so we get our a value from our general form equation. Also, do make a note, since we're dealing with horizontal, when a is positive, greater than 0, it's going to open to the right. When a is negative, less than 0, it's going to open to the left. And just like before, the lattice represents the distance from 2 points on the parabola. So when you're finding the length of the lattice, you're finding the entire length. So to plot the parabola, you take half the length and move up, and you do half the length and move down from the focus. And so these are the general forms for vertical and for horizontal parabola. The main concept, and you can see it in both, is this 1 over 4a. The vertex and axis symmetry we've done before. The new components are the focus, the directrix, and the lattice. Now the focus and the directrix, we took our time to draw the conclusion that the distance from the vertex to the focus and the directrix is 1 over 4a units. For the directrix, it's in the opposite direction. That's why I put a negative. For the focus, it's in the positive for it. And so therefore, that is the key. If you can get that concept down, then graphing parabolas will be easy for you. But the distance from the vertex to the focus is 1 over 4 units. From the vertex to directrix is 1 over 4 units in the opposite direction. That allows you to see these formulas just from finding the vertex and knowing the definition. And it's the same concept for a vertical parabola as well. So like I said, I know this is a lengthy breakdown of our vertical and horizontal parabolas, so hopefully you find it helpful and we can use these concepts to actually apply them to putting them in general form and graphing in future videos.